We have seen, okay, we have seen the first three type of intervals for Fourier series. What was the first interval? We'll take a quick recap and then we'll go to the next. Tell me the first interval we have seen for Fourier series. What was the first interval?
0 to 2
Pi
pi.
to 2 pi.
0 to 2 pi.
0 to 2 pi. Where we have to find what? A naught.
Full inter.
Full range. Yes, very good. Full range. 2R full range. Full range series. First is 0 to 2 pi. Where A naught, A and B n we have to find. A naught is 1 by 2 pi 0 to pi f of x dx. An is, need not to write, just listen, f of x into cos nx dx. And Bn is 1 by pi 0 to 2 pi f of x sin nx dx. Here in 0 to 2 pi you need not have to check for even or. Okay, this is A naught, A and Bn, and we know the Fourier series. Fourier series is every time A naught plus summation an cos nx plus bn sin nx every time, where sometimes their a naught, an or bn can be 0 in case of even or, right? But this is the Fourier
N
series.
is equal to 1 infinity.
Yes, n is 1 to infinity is the Fourier series, right? Where in 0 to 2 pi, this is your work. Full range is first 0 to 2 pi, and then second full range is
Minus pi to pi.
Minus pi
Minus
to
pi
pi.
to pi.
pi to pi. Very good. And where if it is minus pi to pi, what do you first do? Check.
First, find the functions are
Even
even
or neither even nor odd. If it is neither even nor odd, then we have to find a naught, an and bn, everything. Just change will be where same definitions, but change will be in the limits of integration. There will be minus pi to pi, right? If second, if it is even, what will be 0?
Bn will be
Bn.
0.
N is 0. Yes, very good. There will be only a naught and an. Third, if it is odd, what will be 0?
A
A
naught
naught
Zero
and
an.
Very good. A naught and an are 0. So accordingly, your Fourier series will modify. If Bn is 0, this part is not there. A naught, an 0, this part is not there. Summation of this. These two are called full range. Then we go for half range. Half range Fourier series. Which type of interval is there for half range?
0 to pi.
Yes, very good. 0 to pi. And if it is half range, it is of two types. Half range Fourier cosine and half range Fourier sine series. If it is half range Fourier cosine series, Bn is 0. Yes. And if it is sine, A naught and An both are 0. And the definition exactly same as even odd in minus pi to pi. This is where we are up to. And this is about the interval having pi in it. This much type we have to see. 0 to 2 pi, minus pi to pi, even or neither even nor odd in minus pi to pi, and half range, that is 0 to pi. So pi intervals are over. Now exactly similar we have to do for the arbitrary interval. So give the heading Fourier series. Fourier series in C to C plus 2L. Now it is L, not pi. Intervals will not have pi in it. L is any number. You can write L is an arbitrary number. Okay, so such intervals will be there. Now f of x is periodic function. With the period, there will be now 2L period, not 2 pi. Okay, the period is 2L. function is periodic with period 2l, satisfying Dirichlet's conditions. This also continues itself as it is. Then the Fourier series is defined as f of x is equal to a naught plus summation an cos n pi x by l plus bn sin n pi x by l. N is 1 to infinity. Similar definition, everything is same. Now, henceforth, remember whenever there is number instead pi, angle will be n pi x by l, not nx. If it is pi, angle will be nx, and if it is l, angle will be n pi x by l. That l we need to find out. Where a naught is 1 by 2l. Now pi's role is played by l. So 1 by 2l integration c to c plus 2l f of x dx. Everything is same, just the angle and pi is now l. An is 1 by l c to c plus 2l f of x into, can you just tell me f of x into what will be there?
cos n pi x by l.
Very good. There was cos nx while we were doing it in pi intervals. But if it is now L interval, angle is always n pi x by L. So f of x into cos, and Bn is 1 by L c to c plus 2L f of x into sine n pi x by L dx. This is the basic definition when it is interval is having L, arbitrary interval. Now there are again like pi, three types. Which three intervals we are going to see? Can you just elaborate? Exactly similar manner we are moving. So what will be the first interval we have to see here? Intervals. पहिलं तर येईल फुल रेंज. फुल रेंज मध्ये काय काय येईल बोला?
0 to 2 pi.
Pi is now L, 0 to 2L. And then second,
minus L to L.
very good, minus L to L. And then there will be half range. Finally, half range is
0 to
0 to
12.
very good. It is exactly similar as pi interval. So for 0 to 2L, A naught, AN, BN, everything is there. For this type, we have to check even odd. And for this, as even as odd, similar definitions will be there. So first, now give the heading. Fourier series in 0 to 2L. So for what will be the Fourier series? No, I'm not writing f of x is a periodic with period 2L and satisfies Dirichlet's conditions. I'm not writing this directly the definition. Tell me Fourier series in this case. Just remember you have to tell me everything similar as 0 to 2 pi, just the angle you will change and pi you will change by L. That's it. Chalo. F of
A
x
naught
is
plus A naught plus summation of AN cos n pi x upon L plus Bn sin n pi L up n pi x upon L.
very good. Perfect. Sin n pi x upon L, an, bn, n is 1 to infinity. Right? This is the Fourier series where we have to define A naught. A naught is in 0 to 2 pi type interval is this. 1 by
2L.
2L. Yes, very good. 0 to 2L f of x dx. An is 1 by L 0 to 2L f of x into what? For an it is cos n pi x by L dx, and Bn is 1 by L 0 to 2L f of x into sine n pi x by L dx. That L you need to find out value of L. Done. This is the definition in 0 to 2. Solve this, substitute in this, you will get the required Fourier series. Second, Fourier series in minus L to L. And when it is minus L to L, check for even, odd, neither even nor odd. Am I moving the similar way as pi interval? Yes, everything is same, just the angle you need to think. कधी द्यायचं? आचार्स? Okay. Okay. So in this interval minus L to L, we have to check for even odd, neither even nor odd. If f of x is neither even nor odd in minus L to L, then the Fourier series is, what will be the Fourier series?
A naught plus summation of
An
an
cos
cos nx nl.
n pi x by L now, because you have to remember this here. If interval is having pi, then nx. If it is having number, then n pi x by L. N is 1 to infinity, where a naught is 1 upon 2L minus L to L f of x dx. En is 1 by L minus L to L f of x into cos n pi x by L dx. And Bn is 1 by L into sine n pi x by L dx. Done. If it is neither even nor odd. Now second type. If f of x is even in minus L to L, what will be 0?
Bn.
Very good. Bn is
Bn.
directly 0. Very good. So Fourier series is a naught plus summation an cos n pi x by L. Bn is 0. So no term will be there. Next term. Where a naught is, tell me this now. A naught is, it get modified, you know. What is a naught? 2
1
times
upon
होतं.
2
2L जातो. 1 upon
1 by
2L.
L.
1
Yes,
upon
1
L.
by L. Integration
0
0
to
to L.
0
0
to
to
L.
L. Yes, f of x dx. An is
2
2
by
by
L.
2
L.
by L.
very good. Perfect. 2 by L. 0 to L. F of x cos n pi x by L dx. Okay. This is when function is even. Now third type in this. If f of x is odd in minus L to L, what will be 0?
a naught an.
A
A
naught
naught
and
and
L.
An.
Very good. A naught and both are 0. And then the Fourier series is
Summation of Bn
Summation
very
of
good.
Bn
by x
sin
upon L. dx.
Very good. Perfect. Sin n pi x by L. N is 1 to infinity, where Bn is
2 upon L. Integrate
nice. 2 by L integration 0 to L f of x into sin n pi x by L dx. Now, what we have seen is full range 0 to 2L, then minus L to L. After that, it comes half range. We'll write every theory now and then we'll go for examples
Ma'am, 1
later.
minute please. Page turn
Are
on
you
करता थी.
writing? Are you writing?
Yes, ma'am. Yes.
Do it fast, beta. You know we do not have much time. You will get it later, the PDF. If you understand, please don't waste time, bacho. Can I go next?
1 second, ma'am, please.
Write it. Fourier series is all about understanding of definitions. If you understand the definition, 80% part is done there itself because you know how to solve the integration. And you know since 11, 12. So it's just the definition, and in MCQs you will face most of the time the definition itself, not and just the constant term like A naught. A and Bn will rarely be asked to you. Just focus on A naught more and the definitions. All the definitions must be correct. Where it is 1 upon L, where it is 2 by L, where it is 1 upon 2L, and which interval, like this. Done, Snehal, beta, can I turn?
Yes, ma'am, yes.
Okay, chal. So we have seen 0 to 2L minus L to L, that those were full range. Now we go to half range. Half range Fourier series in which interval?
0 to L.
0 to
0 to
L.
L.
0 to L. Very good. There are two types we know. What is the first type? Half range Fourier
Cosine.
Cosine
cosine
series.
series. Very good. Now understand the short forms, okay? CS. C means cosine. Can I write? Cosine. Okay. Half-range Fourier cosine series. What is that series? F of x is same as even function. an is having cos n pi x by L. N is 1 to infinity, where a naught is 1 by L, 0 to L, f of x dx, and an is 2 by L, 0 to L, f of x into cos n pi x by L dx. Right? Exactly same as even function in minus pi to pi, but here interval is not minus L, minus L to L, it is 0 to L. Accordingly, your value of L will change for the half range. Second type is half range Fourier sine series. What is that series? F of x is summation bn sine n pi x by L. Every time think for the angle. Angle is now not nx, it is n pi x by L, where bn is 2 by L, 0 to L, integration f of x sine n pi x by L dx. Done. This is what we have to see next. Now, I'm not writing it separately. You have to identify the interval. You have to solve accordingly, whether it is 0 to 2L, minus L to L, or 0 to L. Go find it and solve. Every theory we have written. Now we'll go to the example. Okay, that's the example. Find the Fourier series, or like write like this. Expand. F of x is pi x in 0 to 1 and 0 in 1 to 2, period 2 with the period 2 into a Fourier series. Expand this function of period 2 into the Fourier series. Okay. Whenever it is a Fourier series, your first role is to check the interval. Now, interval are of two types. First, it was very clear that interval is either 0 to 2 pi. Now, you have to think it differently also, whether there is pi or whether there is no pi. So, which type of interval it is?
0 to L.
Yes, 0 to. Wait, just tell me, is it having pi in it or not pi in it? You have to check the interval, not the function. Interval मध्ये pi आहे का? नाहीये. म्हणजे
No,
हा
no.
pi
No.
interval वाला नाहीये. यामध्ये numbers आहेत. This is of the type L, right? There are two types now, having pi and having numbers. So this is having numbers in it. Do you understand? Now, when the numbers are there, your job is much complicated because the numbers into a Fourier series, they will say, tell you just the Fourier series. So we have to read it properly, whether they have asked you the Fourier series or half range Fourier series. If it is Fourier series, means it is full range Fourier series. Listen properly. Full range Fourier series, they can just call it as Fourier series, right? So if it is a Fourier series, it will compare with full range, and if it is word half range, then it will compare with 0 to L. Yeah, so this is the Fourier series. Fourier series means full range. So full range will compare with either 0 to 2L or minus L to L, two types. So this will compare with what? Which full range?
0 to 2L.
Very
0
good,
to
because
2.
it's, yes, very good, because it is started with 0, not minus 2 to 2. If it is like minus 2 and 2 here, so it will be minus L to L type. Are you getting? If
Yes,
it is
ma'am.
minus, yes, minus 2 to 2, then it will be minus L to L. But it is 0, started with 0, so it must be a full range. And that 0 to 2, you will compare with the full range 0 to 2L. Any doubt in this question? Why 0 to 2L? Why not minus L to L, and why not 0 to L? Anyone? Everyone is clear? You have to compare it with 0 to 2L because it is a full range. Full range are of two types, 0 to 2L minus L to L. It is of the type 0 to 2L, so we have to compare. So comparing these two, you will get 2L is equal to 2. Both are same. So what we get here, L is 1. Like this, in every interval, we have to find the value for L first. That value we'll need in these angles. To find that value first. Okay, you got the value now. Then in 0 to 2L type, we have to write the Fourier series. We have defined it as 0 to 2L type. So in 0 to 2L, Fourier series. Fourier series in 0 to 2L is f of x. 0 to 2L आला की त्यात a0, an, bn सगळंच येते. So f of x is a0, the summation an cos n pi x by L. Don't forget this angle. Don't write nx. bn sin n pi x by L. एकदा की तिथे L समजला की अँगल हा हाच राहील, nx राहणार नाही. If it is not having pi's. Okay, where a0 is 1 by 2L, 0 to 2L. an is 1 by L, 0 to 2L, f of x cos. And bn is 1 by L, 0 to 2L, f of x sine. Okay, this is the definition. We have to solve all of this and substitute in this. That is, we call it as question number 1. Okay, so we go to find a0 first. a0 is 1 upon 2L. L काय? L is 1. So 1 upon 2 into 1. Sorry, 1 upon, no? So 1 upon 2 into 1. Yes. 0 to 2 into 1, that is 2. F of x dx. It is 1 by 2. Integration 0 to 2 of the function, but 0 to 2 breaks at 0 to 1 and 1 to 2. The integration also does as 0 to 1 and 1 to 2. In 0 to 1, function is pi x dx, and in 1 to 2 it is 0, so 0 dx. Okay, so 1 by 2 outside as it is, pi is constant outside, integration x is x square by 2, and this is from 0 to 1. Integration 0 is 0, so this is 0. That is upper lower limits next. That pi will come out, pi by 2. Upper limit is 1, so 1 square 1 by 2 minus lower limit 0, so 0. So pi by 2 into 2, 4 is your A naught. Am I right? You're getting the same.
Yes, ma'am.
Correct? Very good. Chalo, go for AN. Can I turn Snail? Or you're on the right?
Yes, ma'am. Yes.
Okay. AN. Go for AN. AN is definition. Tell me definition.
1 upon L
L.
integration 0 to 2
Yes.
L f
Yes.
of x cos
Very good.
n pi x upon L dx.
Very good. 1 minute. Okay. AN is 1 upon L. L is 1. 0 to 2L. 2 into L. L is 1. F of x into cos n pi x by L, but L is 1. So n pi x dx. Corrected? Okay. Therefore, AN is 1 by 1, 1. 0 to 2 breaks we know. 0 to 1 and 1 to 2. In 0 to 1, function is pi x. Na? So pi x into cos n pi x dx. And in 1 to 2, it is 0. So 0 into cos. Okay. So here we have to solve, this is 0, only we have to solve this. Pi is constant out, integration 0 to 1 x into cos n pi x dx. How do we solve?
UV rule.
Yes, UV, instead UV, we have one rule, famous.
Leibniz.
Yes, yes, U and this is V. If the derivative is getting 0, we can use Leibniz. So pi into U V1, U as it is, integration of cos, sine,
Sin
n pi x upon what?
n pi
N pi.
Very good, very good. Minus derivative of this, 1. Integration of this, integration of sine, minus cos n
minus
pi
cos
x
n pi
upon n pi आणि already एक n pi n
n
square
square
pi square. Very good. आणि याचं पुढचं 0. So this is over from 0 to 1. Okay. So it is pi into. Now we have to put the upper limit. Upper limit is 1. If it is 1 here, sin n pi. Sin n pi is
0.
0.
so 0 into anything, 0. Yes. Minus minus plus. X is 1. Cos n pi upon n square pi square. Upper limit done. Minus lower limit, put x is 0. 0 into anything 0 plus cos 0 upon n square pi square. हे झूम केलेलं बरं दिसतंय का झूम इन करूयात परत?
मॅम कसंही.
चालते ना तुम्हाला? तसंही चालते ना?
येस मॅम.
ओके चलो पाई इंटू cos n pi minus 1 raised to n upon n square pi square minus cos 0 is 1 upon n square pi square. Common thing is pi as it is 1 upon n square pi square is common. Here it is minus 1 raised to n minus 1. एक pi पण cancel होईल. So what we get? Minus 1 raised to n minus 1 upon n square pi an. Check your answer. If any doubt, please ask. Clear it?
Yes
We'll go
ma'am,
to
getting same answer.
okay, very good. Yes, perfect. Chalo, Bn. Bn is 1 upon L. L is 1. 0 to 2L. 2 into 1. F of x into sine n pi x by L. L is 1 dx. Definition. Next is 0 to 2 integration. We have to break. So it is Bn is equal to therefore 0 to 1 plus 1 to 2. In 0 to 1 it is pi x into sine n pi x dx, and in 1 to 2 0 into sine. No need to write, you can write directly 0. Okay, solve this. This one is 0. Here pi is constant coming out. Integration 0 to 1 x into sine. How do we solve?
Leibniz rule.
Leibniz rule.
Yes, perfect. Leibniz rule. Apply it. Pi into u even integration of sine minus cos n
Minus
pi
cos.
upon n pi, right? Minus derivative of x is 1. Integration of this, integration of cos is sine, minus sine as it
Sine.
is. Yes, sine n pi x upon n square pi square from 0 to 1. So it is pi into upper limit. If it is 1, 1 into minus cos n pi upon n pi. If it is 1 here, sine n pi, which is 0. Minus lower limit, if x is 0, 0 into anything, 0. And sine 0, 0. Check once. So only this term is there, minus pi into cos n pi is minus 1 raised to n upon n pi. Pi get cancelled. Minus of minus 1 raised